So we're going to reintroduce the command we used on Friday, which is called mesh grid, and we'll see where that gets us. All right. So I'm just going to do this in the code, and I'm going to do the same way we did it last time, actually. I won't do it. It's a little longer than what's in the notes there. But it'll be, I think, a little easier to follow. Sx, sy. All right. So a few changes. Those last 4 lines there are either new or modified from the original. I can't do that. All right. Those guys there. So if you look in the help menu, I try to use the nomenclature as much as possible from the help menu so that if you look at the help, it looks similar. What we're generating, let's just quickly run this for a second. And I'm just going to take a look at Sx and Sy. What we created were 2 vectors, Sx and Sy, which are exactly the same because they have the same input. But they're 5 numbers, and they're equally spaced between 0 and 1. So that's what the linspace does, start point, end point. And then the 5 is, well, how many numbers do you want back? I want 5 numbers. So it equally spaced them between 0 and 1. What we get out of the x and the y are these 2 grid things here. Let's take a look. All right. So the mesh grid command meshes those, puts those together, joins them. And what do you notice about the x matrix? What values are in there and how are they laid out? Yeah?
They're increasing column-wise?
They're increasing column-wise, exactly. Let me just do a little tweak here so we can actually see the difference for 1 second. I'm going to change my sy here to be, let's go from 10 to 11. No, let's go like 5 to 6. That's 5. And then we'll do our xy command. Nope. Sorry, you have to go back to the editor here for 1 second, just so we can see some different numbers here. All right. So x and y, there we go. So exactly, the x values, whatever was in Sx, I'm going to get the same values over and over again. Every column is going to be whatever was in Sx, 0, 0.25, 0.5, 0.751. Meanwhile, the y values, how do they change? Row-wise or column-wise? Or sorry, where are they? Yeah, which way do they change? Row-wise or column-wise? Row-wise, yeah. 5, 5.25. Every row is identical, but they change as we change rows. Okay. Now, let's put that together with the Tm. So, here it is back the way we had it before. 0, 0.25, 0.5, 0, 0.25, 0.25. What is MATLAB going to do with this? You can always, always, always imagine the computer as someone doing some work with what you gave it. So our inputs, these are the 3 things that we pass to MATLAB. And what is it going to do with it? You have to imagine the calculations. Well, the most natural calculation would be to say, hey, I have a temperature. There it is, 38 degrees. Where should I locate it? Well, I have 2 matrices that are exactly the same size. Why don't I locate that 38 degrees at x equals 0 and y equals 0? So imagine putting these 3 things as a layer in front of one another. Having our x's, then our y's, and then our temperatures. So if you want to know the x coordinate and the y coordinate of a certain temperature, you just line those guys up. Likewise, let's take a different point here. This 72 degrees would be put at y equals 0.25 and x equals 0.75. So it's a very natural way to plot things. I've got a values. Where do I put them? Well, I need both an x and a y to make that work. And I need a grid. So this is where the mesh grid creates something that is 2-dimensional, but it works out perfectly. All the things that are in this column are going to be at the same x coordinate. They're all going to be at x equals 0. Well, that's the way they look in my matrix. They're all in the same column. They're all going to show in the same vertical place on the graph, but with different y values. Likewise, these guys are all going to be in a vertical column at 0.25x. These guys are all going to be in a column at 0.5x, and so on. So maybe not the first thing you would have thought of if you're trying to develop this code yourself, but this makes it's pretty easy to combine these things once you have them into the kind of graph we're looking for. And we can see that in the final result here. Let me go back to the SX or SY that I messed up here. Change it back to 0, 1. And we can see the effect in the graph. Now that 38 degrees is at 0, 0. That 70 degrees is at 0, 1. And the other things go up to 0, 1 as well. So by merging that more specific, not counting 1, 2, 3, 4, 5 like rows and columns, but matching it to specifically the values between 0 and 1 in x, 0 and 1 in y, we've got a nicer scale for our graph now. We actually have a physical scale for our graph now. OK. Show of hands for borrowing a little bit of magic with mesh grid. This is sort of making some sense. OK, most people. All right. There's lack of hands over here. Are there any questions that people want to throw in now before we add one more complication to it? Yes, go ahead. The 0 to 1 again? Sorry, what was the question there? Sorry, it's 0 to 1, but I put a 5, 6 just so we got different numbers, but I changed it back to 0 to 1 because it's a 1 centimeter plate, 1 centimeter plate. That's not quite what you're getting at, though, is it? Oh, OK. So, sorry. Most likely what happened is you forgot to put x and y in the p color. Is that possible? OK, yes. So it's great that you create x and y, and this will happen to everyone, again, before the end of term. You create these great matrices, but then you forget to put them and actually use them in the command that follows. So you have to put them as inputs to the p color command. So it uses all three. OK. Any other issues or problems with people running this? OK. All right. Then we get to the last thing, which is, hey, this is the wrong way around. If this point here should be in the bottom left corner, what y coordinate should it be at between 0 and 1? This bottom right corner, what y coordinate? Let's try this all together. What y coordinate should that lowest number be at? 0. That was not all together. But yes, 0. Why? Because y0 is the bottom. What should the y coordinate of the 70 degrees be? Altogether, 1. Right. So we need to think of this matrix here and go, well, I want this 105 to be at y equals 0. And I want this 70 degrees to be at y equals 1. Well, in other words, I want these guys to go in the opposite direction or opposite sequence that they're going in now. I've got a mismatch between where I want things to show and where they are showing. So that's why we change our lint space. I want my y values to start at 1 and go down to 0, because that's the order it's getting filled in right now. It's whatever I put in first goes top, whatever I put in last goes last. So that's why we tweak our y lin space only. The other one's fine. Left to right's always fine. And we just change the lin space for the y values to change the order. I'm just going to run that. And then we're going to look at our y values. Perfect. Our y values now, the things in the first row are going to be assigned to the highest y value. The things in the last row are going to be assigned to the lowest y value, so they'll show lowest on the graph. And yes, indeed, now we've got our 100-degree hot spot down there in the bottom right corner where it should be in our minds to match the graph to the output we got earlier. And that's the major tweaking we can do with this. All right. So 2 things I'm going to ask you to take away from this. One is the idea of plotting a 2-dimensional object like this using the p-color command. You'll often have to tweak it a little bit, and the mesh grid's the way we do that, to change the layout and possibly the inverting the y direction. That's something you'll be asked to do in a test and sometimes during the project. But there's always a stepwise, what do I have and what do I want correction you can do. You can ask, OK, how do I flip the axes? How do I get the scaling right? It's always a minor tweak, one tweak at a time. If you work on it that way, it's usually a fairly straightforward sequence, maybe with some syntax problems, but conceptually should be fixing one thing at a time. Questions or comments before we go on to something separate? Yeah?
It's kind of
yeah, absolutely.
When I get a plot for colors,
yep.
my range is different.
You mean you get like a red to blue thing? Right. So one thing that I'm very disappointed by in MATLAB is that this color scheme that we get here seems to be the new default. It was, in the old days, like version before this, I think even the last version before this, the default was like a bright red to something else, which I found was far more exciting to look at. So it's just a question of which version of MATLAB you're running. Most of you will probably have red to blue scale as the default. Show of hands, red to blue on your graphs. OK, everybody but me. All right, so that's where it's coming from. It's just a default set by MATLAB. If you want to change that, what you might want to do is say, you know, color bar is what we're using, right, to show the scale. I'm just trying to bring up the help. There we go. So one place to start looking for things is maybe something related to color bar. This is a total guess here. Here we go. So there's some things you can do here like color map. That sounds related to color bar. And blah, blah, blah. So there's a name here. Let me see if this works. Oh, hello. There we go. So if we want to change our color bar to be something a little more exciting, like maybe hot. Color bar hot. That sounds exciting. So again, the help menu is your friend. Where did MATLAB go? Oh, this is MATLAB, sorry. So if you want to change this, you don't say color bar, what was it called? Color map, hot. And if you look at your graph now, ooh, exactly. So it's easy to rearrange, but the default's been changed in my version, that's all. Again, I don't know why.
Why does it go up by 0.1 on the y-axis and 0.2?
Why does it go up? Oh, why does it go up by 0.2s here, by 0.1s? So MATLAB basically has some default. It tries to pick a nice scaling for you. It depends on the size of your window. So I think I could probably, there we go. If I make it a bit wider, it'll go for 0.1s. It basically says, what's a natural fitting of the things? And if you make the graph bigger or smaller, it'll add or remove barrier points. It doesn't usually mean much. Yeah. Good question. As I say, the help menu is a fantastic resource, and then say, yes, you can use it in tests and the exam, absolutely. So the rules for the tests and exams is no external resources, nothing outside the computer. The MATLAB help's built into the computer, so that's totally fine. Absolutely. Yeah? It's actually not a granularity of the colors. Right now, the problem is the granularity of our grid. So we do want to increase our grid fineness, and that'll make this look a bit better. So we'll do that next, actually. Last question about this. Yeah? Oh, sorry. Shh, I can't quite hear the question. Thanks.
On your grid, the warmest side is the bottom side of the square.
Right.
On mine is the right-hand side. So did I just sort of put a sign somewhere or something? Or
Right. So if you are getting the hottest side, oh, is it? OK, if you're not getting that graph, most likely it's because you would have changed both the x values and the y values, their order. The x should be 0 to 1. That keeps it the same order. And the y value is 1 to 0. That's my first guess. No? You've got that?
it looks the same. It's the exact same pattern. It's literally just sort of mirrored.
Like this is put over here. Talk to me afterwards. It might be easier to debug there. Or check with your neighbors. My first thought is the SX, SYs, but take a look. OK. Where are we going here? Right. Notes. There we go. So we've done that, we've done that, we've done that. Fantastic. Oh, yeah. There's a couple of other variations. Sorry, speaking of the coloring, there are a few other variations you can experiment with. The shading is what I'm going to look at right now. So these shading examples. What this does is it just takes away those black lines, which sometimes makes it look better, especially if you've got a really, really fine grid. The black lines can take everything over. So that's one thing we can do. You can also ask MATLAB to do its best to interpolate. So the idea is you've got these 5 by 5 grid, but we know it changes fairly smoothly between one grid point and the next. That's actually how we're doing our calculations. We're assuming things are fairly smooth and continuous. And that can get you the kind of grid you're talking. Was that the kind of picture you're thinking of? Yeah. So it's not actually doing any more sophisticated calculations of the temperatures, but it's using an interpolation to start at the hot corner down here, and the things at 0.8, or sorry, 0.75, 0.75. It's sort of smoothly moving from one to the next. You can almost see some of the straight lines that are being added there. They're not quite smooth parts, but it's pretty subtle. But anyway, this boss is like this more than they like the original grid. I'll fully agree with that. This looks pretty. The other thing we can do with this, too, is generate contour diagrams. Exactly the same, basically anything that has a 2D plot version. So think back to APS-C 172, 0 to 10 to 100. Our temperature grid is like things in the 10s to 30s. And there, we can get these kinds of contour diagrams as well. So you can see where the hot part is. It's down here, and then it cools off as you go towards the top. Again, all these visualizations are alternatives to the p-color plot.